And as I was saying, uh, the relevance that you would be evaluating should be with respect to the information need. But the problem is that you don't know what the information need of the user could be by just looking at the query. For example, if somebody is searching for Python, uh, just from the query itself, you can't tell whether the person was searching for information about Python programming language or about a particular kind of snake or other possible meanings that Python could have. So the best that we can do is to treat the query as a proxy for the information need, while keeping in mind that the real measure of users' happiness is the satisfaction of the information need. Okay. So here's an example of an information need. Let's say you're looking for information on whether drinking red wine is more effective at reducing your risk for heart attacks than white wine. Now, a user could submit a query like wine, red, white, heart attack, effective. Okay, so just by looking at the query itself, it's not clear that this is the information need. So what you'll need to do is you'll need to evaluate the document with respect to the query, not with respect to the information need. Even though the most accurate measure of relevance is with respect to the information need. So there's something called TREC, which basically stands for Text Retrieval Conference. So this is a conference which is run by the National Institutes of NIST, National Institute of Standards and Technology, where every year they do tests on different search engines. So they'll have all these benchmarks that we talked about. They have a reference set of document collection, a reference suite of queries, and then they do evaluation of whether the documents returned by different search engines are relevant to the query or not. And the benchmark document collections include corpora like Reuters, and there are several document collections. And the retrieval tasks are already specified or pre-specified as queries. So this is publicly available. You know, anybody can use these benchmarks to evaluate their search systems. And human experts will mark for each query and for every document whether or not the document is relevant to the query. So once these results have been marked as relevant or not relevant, we need to convert these markings into some kind of a numerical measure for performance. And in chapter 1 we saw that there were two measures, precision and recall, for measuring the performance of an IR system. So the precision is the percentage or the fraction of the retrieved documents that are relevant, and the recall was the fraction of the relevant documents in the collection that were actually retrieved. So you can imagine this kind of a table. So it looks like my pen has stopped working. Okay, I'll use the mouse. So imagine this kind of a table where you have relevant and non-relevant on one side and retrieved or not retrieved on the other side. So consider a particular query. Every document in the corpus could be labeled as relevant or not relevant. And every document could be retrieved or not retrieved for that particular query. Right? So you have all four possible combinations. It's possible that a document could be relevant to the query but also retrieved and also retrieved. So that is something called a true positive. A true positive is a case where you actually have a relevant document and you actually detect it as a relevant document. You're not, it's not just there, but it's something that your search system is also fetching. Then you have something called a true negative, where a particular document may not be relevant and your search system could actually detect it as irrelevant, and so it may not fetch it in the list of results. So that's called a true negative. A false positive is when you are returned a document which is actually not relevant. Okay, it's actually negative, but it comes out to you as if it's a positive case, as if it's a relevant document. It's a false positive. And a false negative is when a document that is actually relevant is not retrieved. Okay, that means your search system is deciding that it's not relevant, that it's a negative case, whereas it's actually a relevant document. So the precision can be expressed by this formula. It's the number of documents that are retrieved and relevant, that means the number of true positives divided by the number of true positives plus the number of false positives. Basically, the sum of these two is the number of documents that are retrieved. So among all the documents that are retrieved, what fraction are relevant? And likewise, the recall measures among all the documents that are relevant. Okay, what are the relevant documents? It's the sum of this number plus this number. Among all the documents that are relevant, how many are actually retrieved? Okay, so notice that the true negatives are not appearing in this formula. Here's an alternate formula and an alternate measure for it. You could think of, think of this 2 by 2 matrix and think about the following observation, that you want to maximize these two, right? Ideally, you want the true positives and the true negatives to be as high as possible, and you want the false negatives and the false positives to be as low as possible. Okay, preferably these should be 0 and these should be uh, obviously what if the sum of these two will always be uh, equal to the number of documents in the corpus. So there's something called accuracy, which you could use in place of precision and recall. And accuracy measures what percentage of your entries are either true positive or true negative. So you have 4 values here, right? So accuracy measures what percentage of these values falls into this true positive zone or true negative zone. So it's the number of true positives and true negatives divided by the total number of uh, entries in this 2 by 2 matrix. So here's a question. Why would accuracy not be a useful metric in the context of search engines?
So, so the true negative may be so high that, like, it would make the value unusable kind of thing, because we'll have
Yeah,
so many documents.
yeah. So for most of the queries in a search engine, what happens is that only a very, very small fraction of the documents in the collection are actually relevant. Right? Most of the documents are not relevant. So um, As a result, the number of true negatives will generally be much larger than the number of true positives. So what's the problem if that happens?
Uh, so the answer will always be close to one. I think accuracy will always be very close to one.
Yeah. So even if you have a really bad search engine, and let's look at a search engine like this, which does not return any results for any query. Okay. So this is a 99.999% accurate search engine on a low budget. Okay. This is all that you have to design. And why does this have 99.9999% accuracy? Because it's deciding for every query that every document is not relevant. Okay, that means so what's going to happen is that most of the documents will actually not be relevant. Okay, maybe 99.9% of the documents are actually not relevant, and it's only 0.1% of the documents that are relevant. But Snoogle.com is deciding that 100% of the documents are not relevant, right? And so if you compute this measure, the true negatives will actually be very high because most of the documents are indeed not relevant for every query. And because this will be very high, this fraction will be close to 1 even if you have such a bad search engine. Okay. So that's why accuracy is not a good measure for search engines. The other thing that we have to note is that people who actually use search engines have some kind of tolerance for junk results. Okay, as long as they get what they need, it's okay even if a few results are not, uh, relevant to them. As long as there are some results that they are seeing which are highly relevant. Now there's a trade-off between precision and recall, as we have discussed earlier. You can get high recall by retrieving all the documents for the queries, as we just saw. I mean, of course, this is high accuracy, but if you were to just look at recall, you can optimize recall by doing something complementary to this. Okay, so this has a very high accuracy. If you want to get a high recall, you return every document in your collection as the result. But the problem then is that the precision will be low. And if you want to have very high precision, then you may end up um, ignoring documents that are relevant simply because they didn't score that high. So there's usually a trade-off between precision and recall. Now, here's a point. Recall is a non-decreasing function of the number of documents that are retrieved. Can anybody explain why this is the case? What this means is, if I measure the recall for the first 10 documents in the results, and if I measure the recall for the first 20 documents in the results, and then I measure the recall for the first 30 documents in the results, and I keep noting down the values of recall that I'm getting, that's going to be a non-decreasing function. Why is that?
Number of more and more documents are recalled. Like it's it.
Actually, let me take a name. John Paul. Is John Paul there? Would you like to answer? If you don't want to answer, pick one of your classmates' names and pass it on.
I'm not this answer. Syed.
Sir, can you repeat the question, please?
My question was, if you measure the recall as a function of the number of documents retrieved, that means if think of um, think of the list of documents that are returned to you by the search engine. Let's say you calculate the recall for the first 10 documents. Then you calculate the recall for the first 20 documents. Then you calculate the recall for the first 30 documents. Then you calculate the recall for the first 40 documents, and so on. The values of recall that you'll be getting will be non-decreasing. That means they'll either be the same or they'll be increasing. Why is that? That was the question.
Okay. Recall value is going to be
Yeah, so recall is yeah, go ahead.
the relevant documents which are retrieved, right? So, so every time the number of documents increase,
Hmm.
the relevant documents which are considered also increase.
Yeah.
Increase or
Either
either
I,
stay the same.
yeah,
Relevant documents which are retrieved are either going to be the same or
yeah,
it's going to increase any which ways.
yeah, that's
Cause
true.
of which, cause of which the value is either increasing or it stays the same.
Yeah, yeah, that's right. So basically, your denominator remains the same because the number of
Yeah.
relevant documents in the corpus is the same, but the numerator is non-decreasing because if you're considering more and more documents, if you're considering a larger and larger subset of documents, then more and more of the relevant documents are going to find their way into that subset.
Yeah.
And so your recall is going to um, increase or at least not decrease. Now, what about precision? Somebody else should answer. Let me have another name here. Namita Vasudeva.
Precision will decrease, correct? No.
Yeah, precision will decrease, but what's the reason
Smaller
for
the
that?
smaller the document, higher will be the precision, sir. So when the
Smaller.
document,
Mhm.
yeah, so when the document size increases, the precision will decrease.
So we are talking about the number of documents here rather than the size. By size, do you mean the number of documents, or
Yeah,
you're
yeah.
looking at the physical size of a document in terms of number of words in it?
The number of documents.
Yeah. So what you're saying is if the number of documents increases, precision will decrease. And why is
Yeah.
that?
Why is that?
Mhm.
Decrease the age of the number of the documents. You know?
So think of your Google results, right? Search for a query, get a ranked list of results. If you were to calculate the precision for documents on page 1, then you were to calculate the precision for documents on in page 1 and page 2. Then on page 1, page 2 and page 3 of the return results. The precision will keep going down. So I'm asking the reason for that.
Not sure. What? Adi, what is answer? Tell me.
Sir, every document that is retrieved may not be relevant. Every subsequent document may not be relevant, sir.
Yeah, so basically the most relevant documents are the ones that are appearing at the beginning. I mean, this is not guaranteed, but in general that will be true. And so as you go down and down the list, the proportion of documents that are not relevant that you'll start seeing will be higher and higher. Right? And finally, finally we know that only maybe 0.1% of the documents are relevant. So think of continuing on and on and on till you hit the number n, where n is the number of documents in the corpus. At that stage, your precision will be very low, right? It will be close to zero because only a small fraction of the documents are relevant to you. But if you look at just the first 10, precision is very high. And as you are looking at 20 documents, 30 documents, 40 documents, and so on, your precision will be going down in general from that high value, which will hopefully be close to, you know, at least 90 or 80 to 90%, and then going down all the way down to 0.01% or whatever the final value is, right? So, I mean, intuitively you can see that this is what you expect, even though, theoretically you can't prove it, but intuitively I hope you can see that. So recall is non-decreasing, precision is decreasing as you consider larger and larger number of documents starting from the top of your list.